5 to 6 year or some 10-year back, we had a STM network actually. Basically, we had our transmission or access network is actually even access, even aggregation network also was ours actually SDH based. So from there actually we brought up MBLS. MBLS, what we are actually installed is with the MBLS transport profile, that is our CPAN. So there we have some constraints. Then finally we came up with the MBLS IP. Even I think somewhere industries are moved further also, something like segment routing and order. So what we will do, we will have some familiarization. So just I collected that Tanjavur BA MAAN diagram from our EMS itself. So from the diagram, we will be seeing some 4C nodes only in the BA. Actually, it is a geographically vast area, I think, and it is in one way it is better connected only than other places. Is a better connected. Maybe can be after our discussions also, and some maybe can be improved in later stage if fiber availability is there. This I just shown. This is the actually what I seen in the EMS. This is the connectivity actually. So we will start from the things, basic things. Actually, still we are using the STM1 CPs, and even MADMs are also working in somewhere. Then why we are migrated from SDH to MBLS based network? Even CPAN is a MBLS based network, but it is a curtailed form of MBLS IP. So we have many things limited. So why, at least why we are moved from SDH to MBLS? It is a question actually. It should be why we are transformed from a SDH scenario to MBLS, because SDH scenario have actually lot of protection mechanism. Even individual events can be monitored at any level. Even many, because it is a robust in the management. Actually, MBLS is not so robust as SDH actually. SDH is a, what we can tell, is a very much proven technology, and so many things are there. But why we are migrated from SDH to MBLS or any Ethernet based? So that was the initial changeover actually. Even BSNL was procured STM64 ring. Means STM64 ring means it is a 10G ring actually with the MADM or ADM capabilities. Then why shifted to CPAN? Actually, in SDH, whatever things we are configuring, okay, I am configuring 1G bandwidth for one LCO, so I have to spare 7 STM1. Let him use or not use, I have to keep always this 7 STM1 for that LCO. So I am creating one 1G link for him. As I am offering him a 1G bandwidth, I have to always keep it this bandwidth statically for him. He will be static only. So what will happen if I have a STM64 network also? I can provide some maximum 10 LCO, or if I curtail 1G with some 4 STM1s, so I am providing him 600 Mbps also. So I can go up to some 15 or 16 LCOs in a STM64 ring itself. So rather you can see in our CPAN rings, we may are connecting some 10 or 20 or even 30 LCOs in a one network. Because why means here actually actual traffic only will carry to the network. Actually, how much the LCO is using, he may be using some 100 Mbps only. So that bandwidth only will be there in the media or in the fiber or in the network. But when it was in MADM network, even the customer was using 10 Mbps also. If we are configured for STM, or it means a 1G network or a 7 STM1, we are done a VCG and G generic frame protocol we are done, then we are made it as Ethernet. These things, it will be always there. If we are customer is not sending any data, means ADM itself will generate a dummy data and send it. It will be there always. But when it is come to Ethernet, whatever customer is sending, that data only will be there. So even though we have a backbone of 10G network, we can have a optimum utilization. We may can give some 30 or 40 1Gs. There is no issue because all the customer will not use always 1G. Some people may use 100 Mbps. Some may use, and their usage time also may be staggered. So somebody may be using the peak time maybe 9 o'clock. Somebody's others will be at 10 o'clock and all these things. You need not have to manage in a hourly basis or these things. So that advantage, it is a simple advantage we brought. Actually, technically, many things are there. So what I just try to tell, these are the basic advantages and why all the ISPs are that time gone to MPLS TP. There also constraint was there why it is MPLS TP, why it is totally not in a MPLS IP platform. One actually we have that time MPLS network. That MPLS network is our NIB core. So NIB core routers are limited in numbers, not the huge number like we want in the transmission scenario. In transmission scenario, even each exchange we need a router, or each BTS location we need a router. So in transmission scenario, the router number of routers will be huge, will be rather than the NIB core or anything. So when router number is huge, when routers has to identify the another router or where it is placed, the router have the higher processing capacity. So if we are implementing fully an MPLS IP, we may have very best router than our NIB core routers in transmission. So what that time they curtailed some functions of MPLS IP. Something like usually now when we are doing the tunnel in CPAN, we are actually giving the label. That means whatever things in the MPLS IP, that is label distribution for a tunnel. When we are creating a tunnel, there should be some label should be allocated for the tunnel to identify it. So that we are doing centralizedly from a NOC. So NOC person is giving the what is there to as a label and where to terminate and all, and how route that what are the automatic routing function also we are disabled in MPLS TP. So when we are creating a tunnel, it will take one path in one direction and another protection tunnel also will be there in that two path only. Even we had a third path between that two routers, then also without manual intervention that traffic will not restore if any case both these paths were gone down. So that was the situation. But what was the advantage? We need not have the so much processing or so much processor in our routers. So fiber home is given as a most cheap, means it is a very good equipment, but it is not so costly. But it's a links having MPLS enabled only, but many functions are of MPLS IPs were curtailed. And later we had a development, and all the ISPs were felt the need that always we cannot do manual rerouting, and the time means if and there is a issue, somebody has to alert us when our failure is there. Sometimes tunnels may be gone faulty, we may not be knowing, and many reasons traffic's going down. So there should be only solution is that traffic should get automatically routed. Even though if path is there, it should switch over within the less than 50 millisecond delay, whatever the industrial standard things. So the solution is ultimately we have to move to MPLS IP based network. And as the technology grown, the requirement also has came from L2. Earlier it was we were knowing the customer want 2 Mbps. That may be PRI or Ethernet, internet, or whatever things they were asking in the even level, or 2 Mbps, 4 Mbps level. So later it was changed to L2 Ethernet. They were giving us something, and maybe I want some 100 Mbps circuits. Now scenario itself is changed. They were connecting us with as a L3. They were giving us I have a location, I have a router. I want to connect a router at Chennai, or I want to connect a router at Cochin. So I don't need to know what infra you are using, but I need the connectivity, and it should work like I am sitting in a same office. So the requirement is grown. So all the ISPs are changed to MPLS IP based network. So hope this slide, maybe the transition phase may be not so technical. Only the difference I tried to convey. Why the basic difference I tried to convey. Maybe hopefully it is okay. Then this is the, I think already some parties explained why we are changed to, and what is the NBL L3 network. So with the network, why L3 network means we should be able to provide a L3 VPN or L3 solution, layer 3. Layer 3 means it is a simply IP based IP. So whatever things I am getting data, there will be a source IP and a destination IP. Just like our address, from where to where I have to go. I have a sender address also there, then receiver address also there. I have to route this packet, means I have to find the way for this packet from sender to receiver. This is the thing now my network has to do. I am getting some packets with the means IP packets. I have to take these IP packets to the person where to reach it. Simply just like a postman. So that was the now network requirement. Earlier we were getting simply something, some VLANs where they were giving some VLANs. Okay, some VLAN 100 I have to pass to some other location. Here I am getting an IP, and the IP I am getting, and I maybe this IP I am giving at India. Somebody sitting at London also may be there in the MAAN network only. So this someone new. Hello.
Hi, River sir, can you mute?
Okay. So there are actually many advantages. So we had a limitation of VLAN because, as you know, the maximum VLAN numbers can be 4096. Here we n number of services or IPs we can use in the different VRF or something. This concept we can explain very detailedly later. Just by so just here as a technical word, if not familiar, then we can make it as a hierarchical routing. Anytime any router we can add it to the network without disturbing the existing topology. So when we are having even CPAN or even our MAAN cases, when we have to add a one network element to the existing ring or topology, we have to do a lot of work. So that much things we need not to be done in the L3. And we have the resilience because it will be network will be resilient actually if we have some n number of paths, that path will be automatically taken. So here also some paths are there. Whenever if at all this is going cut, it will be routed via any of the available paths. And there is actually that should not be now. Okay, there is a bit issues in the MAN network that can be easily settled, and it can be done also, and almost it is a in a better manner now than now they are made it very much better than the previous what we got actually. And we can do the traffic engineering, that which link has to carry how much traffic, and which link can be, and which link I have to prefer. All this thing I can do in the traffic engineering part of the this network, and we can offer anyway this MBLS VP MBLS L3 VPNs actually. We are giving the L2 VPNs from one point to another point. We are extending a L2 path actually. Even through with the CPAN also we were extending a L2 path only. Now we can have the L3 path in that. Now just I added one slide extra here. It is actually many times we are hearing actually many times means we should know what is actually what is routing actually. Because earlier itself I told once routing means it's a process. The router determines the optimal path for forwarding IP packet across the routers to reach their destination. It is simply that I am getting a package. So I'm getting a packet in the Cochin at Kerala. I have to make this packet available at Chennai. So I am giving to one network actually. So that network will have routers at means Ernakulam or Madurai or Trivandrum, then at Chennai and all these things. And this routers has to decide how this packet has to reach the Chennai. This is the process of simply meaning as routing. Actually, whatever I am getting, I'm giving to some equipment. That equipment is deciding to which interface I have to hand over this packet, and then it has to ultimately go to fiber through some DWDM or OTN, and it has to reach to some other router. Then that router in turn has to send to any of its interface. Actually, interface means any of its port, and the data will further move and goes up to Chennai. So the function that each that equipment is doing is called by the things routing. There is a way, there is only this is a simple thing. So there will be some matters also. What is actually some technical words also we are using actually connected routes. So some most probably whenever we are seeing in the MAAN routes routing table, we will be seeing means routing table don't be frustrated. Routing table means if I am getting many packets and where all this has to send, which interface has to send, there is a table of data where I have to send. This is only routing table it is there. So usually it is a very simple where if I am in I have a router with locally with me, just like your A3 A4 node. If anything I am connecting locally, just like your 4G BTS. Actually 4G BTS giving some routes actually, some IPs actually it has to be. I have to connect to Trichy or I have to connect to their NMS or I have to connect to their MME or their data center. So that routes I am getting, that IPs I am getting from BTS, that I am connecting to one of my ports as a layer 3. So whatever I am connecting in that A3 nodes or A4 nodes, that will be your connected routes. Then in that BTS, anytime if you log in, there will be a static route also there. So your management IP will be always given as a static route to the most that is 0.0.0/0 IP means it is forwarding to some interface, and the way if you are given statically by UR itself is giving one route. If this IP comes, it has to move to that port means it is a static route. So these things are actually for just in the further series of talks we may repeatedly using these things. So don't be take it as a very technical thing, but it is a word meaning itself. You will get the what it meant actually. Actually, in the routing means as a equipment we are programmed it. We have a just like a computer type device. It is programmed such a way that if I am getting a packet, what I should do. So this is only the routing does. So that router actually determines where actually go. Where actually go means if a person is sending one letter to another person at another place, means like okay, let him be at Chennai. The intermediate person will take the most what will we tell longest prefix. Once you will take the if you have so much address, his house number is there and his location is there, and somewhere nearby this temple, if it is there up to there, he will take that address only as a final destination. So like routers also is configured such a that the longest prefix means the shortest address to where I have to reach, that only will be taken. Routers have one advantage, or it is programmed such a way that if there is no path I am getting in my routing table, in my address book, I am not getting any address to this fellow, then I will simply drop it. I will not give to anybody. I will simply drop it, let it be there. I will not forward to anybody. You take it, and if you know him, you give it. That way router will not do. That way our switches will do. So router have one thing, it will give to the specific person only. If you are not getting, okay, if you are going in a specific location, then it will be very good. If it's not, okay, if it is somebody is going to Chennai, it will given to Chennai person. If there is a no address to Chennai or nothing, then he will be dropped, simply let it be there. This is the concept of routing actually. So we will start with the very basic things actually. uh, what is actually, oh, so I'll hope I will have one small post. So whatever I told, if it is conveyed or not, I want to want a feedback from any of. Okay, sir.
You can continue the bits. Very clear.
So we will have a basic thing. So I have two routers. Say I have one router at a, so I will tell the local name or symbol.
It is not visible. Can you
Okay,
show it any diagram?
okay, that.